Hi everyone, welcome back to our channel where we discuss everything IGCSE Mathematics. So today we'll be going through the paper walkthrough of the paper 1 of the additional Mathematics IGCSE paper, code 0606. Okay, this is the May-June 2024 papers. The code number for this paper, I believe, is /11/M/J/24. Okay, so before you start, please remember that all these handwritten solutions is available for download under the link below. Okay, so without further ado, let's see how we can do this paper here. Let's look at question 1. So on the axis, sketch a graph of y equals to -1/5, x plus 2, 2x minus 1, and x plus 5, multiple x plus 5, setting the intercepts with the axis. Okay, great. So just understand for cubic graph, it's either it looks like that, okay, or it looks like that. Now, if the coefficient of x cubed, right, the coefficient of x cubed is negative, we're going to take this shape here. So when it's positive, we're taking this shape. Right, so we essentially need to draw like that, something like that. But the other thing is also we need to understand, we need to find the intercepts of this curve here. So we're going to solve for them, right? So very quickly, we're just gonna let y be 0, okay? Then this guy will be 0 equals to -1/5 x plus 2, 2x minus 1, and x plus 5. Essentially, by zero factor theorem, all the terms here, x equals to, will be 0. So x minus 2 or half or -5. So just plot on the axis here, okay? Just try to draw to scale so that this is -5. So this is -2 over here, -2, then this will be half. So half will be much smaller, right? This case here. So there you go. Now we can draw the cubic equation here. So cubic equation here would be here. Draw this out. We just slowly draw it. Okay. There you go. There you go. Okay. So this is the curve here that we're drawing. Then we do some touch up. So when x is 0, we need to find the y-intercept. So x is 0. So very quickly, y will be -1/5. This will be 2 multiplied by -1 multiplied by 5. Just replace 0 in it. Right. So this case here, what we'll get is +2. So the intercept here will be 2. Right. So that's that. So let's look at part B. So hence solve for this inequality here where this cubic function here is more than or equals to 0. So if you look at this graph here, anything above the x-axis will be, anything above here will be y bigger than 0, right? Then after which everything below here will be y less than 0, and this is y equals to 0 for this x-axis here. Now because we need to be at least 0, so essentially we just need it to be above the y-axis, and also so the inequality here will be from -5 to -infinity inclusive, and after which from here to here, okay? So inclusive as well. So the inequality would be, from graph, we have got x at most -5 or x between -2, x to half, okay? We need to include 0. So we are taking anything that is above the x-axis and also on the x-axis, okay? Let's look at question 2. We are told not to use calculator in this question. So the polynomial p is such that px is a cubic equation here. So 6x cubed minus 3 5x squared plus 3 4x plus 48, sorry, cubic expression. So find px in terms of in this form here. Okay, so what we need to do is essentially I'm just gonna divide by 2x minus 5, right? Okay, so how it works is this. If say we have px is given by 2x, because we need to express in this form here, so we need to just divide. Px has to be, you have to divide this both sides by 2x minus 5. So this will be qx plus r over 2x minus 5, right? So if I were to divide this by 2x minus 5 throughout, I'll get this expression here. So in other words, I just need to perform a long division to determine the quotient here. Right, so that's that. Just try and do that. So this case here, what I'm going to do is I just take 6x cubed minus 3 35x squared plus 34x plus 45. Just divide this by 2x minus 5. So this case will be, to get 6x cubed, what I need to do is just multiply with 3x squared, right? So 3x squared multiplied with 2x will be 6x cubed. So that's what we want to get, 6x cubed minus 15x squared. Then minus this out. What we get is minus 35 minus 15, which is plus, which this will give us negative 20. Okay, x squared plus 34x. Then do a long division again. Multiply by negative 10x here. So this will be minus 20x squared plus 50x. Right, then minus off. That will give us minus 16x plus 45. Okay, so this case, lastly, we just multiply by minus 8. Minus 8 multiplied by minus 2x will be negative 16x. Then 40. Okay, minus this out. I'll get 5. So this case here, I could write px divided by 2x minus 5 given by this 3x squared minus 10x minus 8 plus the remainder. This is a quotient divided by remainder. So 5 out of 2x minus 5. So px will just be 3x squared minus 10x minus 8, 2x minus 5 plus 5. So you write it in this form, just multiply by 2x minus 5, we get this. So this will be our qx here. This is our r, right? Great. Let's look at part B. So hence, write the expression px minus 1 as a product of linear factors. So minus 5. What we do is just rewrite this entire thing here. Px is this thing, right? We just write it down. So this is 2x minus 5, 3x squared minus 10x minus 8 plus 5 minus 5. So all I did was I just replace my px in, including the negative plus 5 there. So this 5 minus 5 will be 0. Then I could just see what I'll get here. This will be 2x minus 5, 3x squared minus 10x minus 8. So we could just factorize this, alright? Although they say could not use calculator, but we could check using calculator. So just key in calculator, we'll see what we get, alright? Okay, we just factorize the 3x. So go to equation, then go to polynomial, then their degree of 2, put 3 minus 10 and minus 8. Okay, then solve it, then we get 4 and 3x. This is 3x plus 2. So but we could factorize this. Okay, just check the, so again, I'm just going to use a normal table method there to do it. Okay, what we get is 3x squared minus 8 minus 10x. So be 3x x. Then I need this to be 4 and 2. So this is 2x, and this will be 2 times x is 2x. 3, this is 12x. So I need this to be negative. So negative, negative. Right. So if I factorize this, I'll be 2x minus 5, 3x plus 2, and x minus 4. So it tallies with what we found here, right? So that's that. So that's how we do part B. So hence write down the solution for this equation. This equation here, px equals to 5. So px equals to 5. I move the minus 5 to the other side. Minus 5 equals 0, which is this entire thing here, which is like 2x minus 5. Okay. Then 3x plus 2. X minus 4 equals 0. So the roots are x equals to 5 over 2 minus 2 over 3. And or x equals to 4. Okay. So that's how you do this question here proficiently. Let's look at question 3. So write down 1 plus log x squared minus 1 and 2 log x minus 1, right? As a single logarithm to base of 10, giving answer in the simplest form. Okay, I think just express it. So 1 plus lg x squared minus 1 minus 2 log x minus 1. We just want in one single logarithm. So essentially just understand that we could use the power rule. These two could be brought up here. And 1 is nothing more than just lg 10. Right. So is that? That's a base of 10. That will be LG10 plus LG x squared. Okay. X squared minus 1. Then this is LG x minus 1 square. Then what we can do is this plus, right? LGA plus K. So this is the product rule. Just this will just be LG 10 multiplied by x squared minus 1, right? Okay, of course you can just divide straight if you are proficient. Then this case here, if this case, if it's minus, then you just do division. So it's a quotient rule. So L G x squared minus 1 x minus 1 square. Okay, that's it. So you want in simplest form, but don't forget that the top is a difference in square. What we can do is just x minus 1 x plus 1, because this is nothing more than just a square minus b square is equal to a minus b. This is 1 square, right? Multiply by a plus b. Okay, so that's the tricky part there, because you want the simplest form. You have to check whether you need to so this over here, then will be x minus 1 square. So what I can do here is I'm just gonna cancel this out. Okay, so cancel this out 1. So what is left behind is nothing more than just LG 10 x plus 1 over x minus 1. There you go. This is one single logarithm to base of 10. Let's look at part B. Solve this equation here. So we are told to solve this equation 9. Give you answers in the form of a plus b root c. Okay, so what we can do is change it to the same base. We can change to a base of 5 if you want to. So I could just change the base of 5, remember. So this case here, we have 4 LG 5 x plus 1 equals to 9 L log x plus 1 5. So by changing our base, will just means that, for example, remember the change of base is just LGAB is equals to LGCB over LGC. Okay, so you just write LGC, whatever you want to change to, you just put the B on top and A below. Okay, so this case here, what I can do is I just change it to base of 5 for both if you want to. So LG5, so put the 5 on top here and the x plus 1 below here. Very easier. Okay, so this will be 4 LG5 x plus 1. Great. So this case here, LG5 base of 5, log 5 base 5 will just be 1. This is just 1. Okay, so this is just 1. Then what we can do is just cross multiplying. So okay, we put this down, log 5x plus 1, 4 log 5x plus 1. And do we just multiply both sides, just LG5 x plus 1 square. This one we multiply on top, right? This is just square. Just be mindful, this is, you can't bring this down. Okay, this multiply with this will just give you the entire thing square. Okay, so this be mindful a bit. Okay, so then what we get is LG 5x plus 1 square equals to 9 over 4. Open square root. Okay, maybe just open square root will give us LG 5x plus 1 plus minus 9 over 4, which is equal plus minus 3 over 2. Right. Once done, we get x plus 1, 5 to the power of plus minus 3 over 2. So x is equals to 5 plus minus 3 over 2 minus 1. We want it in the simplest form, which is a plus b root c, where a and b c are constants. So this would be square root 5 plus minus 3 minus 1 x. Okay, so anyway, I could just multiply root 5 cube, then this is just plus minus 1 if you want to. It's easier that way. So just take note, the root 5 cube is nothing more than just root 5 multiplying by itself 3 times. So this is just 5 root 5 because this is just 5, right? Root 5 multiplied by root 5. So in this case, will be x equals to 5 root 5 plus minus 1 minus 1. So hence, x will just be equals to 5 root 5 minus 1, or 1 over 5 root 5 minus 1. So obviously, we could just multiply root 5 and root 5 here, rationalize the denominator. So x will just be equals to 5 root 5 minus 1, or 1 over 25 root 5 minus 1. Okay, so that's how we need it in a plus k. So I'll just move the constant to the front. There you go. So that's how we solve this logarithmic equation here. Let's look at question 4. So the first 3 terms in ascending power of x, right? In the expansion of this are given by this, right? So where n, p, and q are constant, find the value of n, p, and q. Okay, great. I think the first thing is to understand when we do binomial expansion, there's always a pattern to it. So I always encourage students to see it as this. First 3 terms, what we do is just bracket like 3 groups of such stuff, right? 3 groups because you need the first 3. Then you start counting from 0. Okay. So what I meant is this. So it's 0, 1, 2. Then you need to ascend the power of x with 0, 1, 2. And then this is n minus 1, n minus 2. Okay. That's that. So this first 3 terms. So n choose 0 is just 1. Then this will be 3n. So 3n. Px is just 1. Okay. So this is n choose 1 is just n. The 3n minus 1 px. Okay. So 3n minus 1 px. Then 3 choose 2 is just 3. Sorry, this is n choose 2. N choose 2. N choose 2 is we know n choose 2 is basically n minus 1 over 2 factorial, right? So this case will be n minus 1 over 2 factorial, and this will be 3n minus 2 p square x square plus this. Okay, so then what we need to do is just compare the coefficient, and then we just try and solve for it. So this is 2, 4, 3 plus 810x plus qx square. Okay, so I think the get-go, we know 2, 4, 3 will be equal to 3m. Then after which we know that, say, 810 is n multiplied by 3 to the power n minus 1 multiplied by p. And also we know that q is given by this entire thing here. Okay, which doesn't look welcoming at all. So by comparing the coefficients, we know that 2, 4, 3 is equals to 3n. 810 is equals to n, 3n minus 1p, and q is equals to n minus 1, 2, 3n minus 2p square. Great. So then what we need to do here is, this is 3 to the power of 5. So 3 to the power of 5 equals to 3n. So we know n is equals to 5, right? So then this case here, this 810, we have n equals to 5 now. 810 equals to 5, 3, 5 minus 1p. So p is equals to 810 over 5, 3 to the power 4. Key in calculator, this will give us p equals to 2. Okay. So then we know that q will just be equals to 5 minus 1 over 2, 3, 5 minus 2, 2 square. Which gives us q equals to 1080. Which makes us n equals to 5, p equals to 2, and q equals to 1080. Okay, great. Done with 4a. So let's look at find the term in the matter of y, giving your answer in exact form. Okay, so just understand that the n term will just be 6 choose r. Okay, we have 2 terms here. This is the term, the general term, tr plus. So this is 2y. And this is minus 1 over 3y squared. Then we need this to be, this is r, and this is 6 minus r. Alright, so just separate them up. 6 choose r, Then this is 2, 6 minus, so just distribute this power to the 2 and the y. Similarly, for the one inside 6r, this will be 1/3 and 1 over y square. Okay, separate them. So this r can be multiplied, can be distributed in. Okay, like that. So what we get is 6r to 6 minus r, y 6 minus r, minus 1/3 r, and 1 over y 2r. Okay, so this case here, what we're just going to do is just rewrite everything, and then we group the y term together. So this minus of this. Okay, so that'll be minus 1/3 r, then the y 6 minus r minus 2r. Whole goal here, the term independent of y would mean that we just need this power to be 0. So just simplifying this would be 6r to 6 minus r minus 1/3 r, y 6 minus 3r. Okay, term independent of y happens when 6 minus 3r gives us 0. Okay, when the power here is 0, so that y to the power of 0 is just 1, so r is just 2. Okay, so just do that. Then the term independent of y will just be, we just replace into this. Replace into this, right? So this term here, independent, this term, the coefficient. So the term, I'll put 6 choose 2 to the power 6 minus 2 minus 1/3 the power square. Just key calculator and we'll get 80 over 3. Okay, so that's how we do this question here proficiently. So let's look at this question here. The diagram shows a graph of y equals to a cosine bx plus c for this domain here, where a, b, and c are constant. Find the value of a, b, and c. Okay, great. So I think the first thing is to understand that we could find a and c first. Okay, c is just a line of equilibrium and a is just amplitude, right? So we try. We don't have this is clearly the line of equilibrium, right? So this is where y is equals to -4. Okay, I believe y equals -4. So in other words, c is just -4. That's pretty okay. So y equals to -4. C is just -4. Now then, after which we ask ourselves, cosine starts from the peak, right? So because this a has to, if it's a negative value, then it will start from the bottom up, right? Like that. But this case here is positive. So essentially, we know that a is positive. Then also, we look at this, we count out this amplitude here. Okay, this amplitude here will give us a grand total of 5. Right? So that meaning to say a is 5. All right. The tricky one is actually b. So you ask yourself period. Okay, so when you talk about a period of the is 360 degrees divided by b, right? So think about it. What is the period here? Okay, we have a period. So this is one quadrant. You need 4 quadrants to form a period, right? So this is one quadrant, which is 120 degrees. Then second quadrant is 240. Okay, then this is 360. So obviously there's another way to go, because we need 4 quadrants. So it'll be the period will be 120 degrees multiplied by 4. Okay, because one quadrant is 120 degrees. So that's that. So just write that down. From here, what I know is that period is 120 multiplied by 4, which is 360 divided by b. So we solve this, we can get out b, right? So this will be 480. This is 360 divided by b. So b is actually 360 divided by 480. There you go. So 360 divided by 480 will be 3/4. So b will just be 3/4. So that's how I do this question here proficiently. So the line y equals to p is tangent to the curve. So this is a horizontal line. Okay. So to the curve of y equals to 3 minus 2 sine. So sine, we know sine looks like that, right? So sine looks like that. But we don't really need to care because the idea is the tangent, horizontal line tangent will only be the top. Basically what we want is the top and also the bottom, right? So these are the two lines that we are worried about. So when we draw the sine curve, we know that it will look like that. Okay. So we want these two equations, y equals to p, y equals to p1, p2. Okay, that's that. So we know that the c, this is y equals to 3. Okay, this is y equals to 3. Maybe I draw the axis here. Okay, we know y equals to 3. Then the amplitude is minus 2. Oh, minus 2 meaning it will flip. But it doesn't matter because it looks like that, right? Okay, we don't really care if it's so this is 2, so this will be 1 and this will be 5. So essentially p will be 1 or 5. These are the two possible values, right? So you just want the horizontal line to be 5 or 1. So that's it. So that's how you do this question here. So let's look at question 6. Find this definite integral from 2 to 4. Okay, so I think this is pretty okay. So we're just going to integrate this 2 to 4. Then we just put this as 2. 2x minus 3 minus 1 minus 3. 3x minus 5 minus 2. Okay, then put this as dx. And once done, what I do is just put 2x. Oh, this is ln, right? This which is power of -1, you can't divide by 0. So you get ln 2x minus 3 over 2. Don't forget to divide by the coefficient of 2. Okay, so if it's -1, you add 1 to a -1, it'll be 0. You can't divide by 0. This will be 3x minus 5 plus 1, which is -1 minus 1 divided by 3. This will be 4 and 2. All right, so that's that. So I'm gonna just rearrange everything nicely. This 2 and 2 will cancel away, 3 and 3 will cancel away. So it's ln 2x minus 3 plus 3x minus 5. Okay, there you go. And you're just gonna substitute the value. You need exact value, so leave it there. Ln 4, 2 multiplied by 4 minus 3 plus 3 times 4 minus 5 minus of ln, then just minus off when you substitute x as 2. 2 times 2 minus 3 plus 3 times 2 minus 5. Okay, just this will be ln 8 minus 3 ln 5. 12 minus 5. 12 minus 5 will give us 7. 1 over 7 minus ln. Ln 1 is 0. So we can just leave it at 0. And then this will be 6 minus 5, which is 1 actually. So this will give us ln 5 plus 1 over 7 minus 0 minus 1. So you just simplify it. This will be ln 5 minus 6 over 7. Okay, that's how you do this question here. Great. Let's look at question 7. So given that 2 plus cot theta is equal to 3x and sine theta is root y. Okay, great. So just understand that cot theta and sine theta, they are connected. Cot square and cosecant square, okay, they're connected by this formula here given in the booklet, which is this cosecant square a is equal to 1 plus cot square a. Okay, I'm gonna just borrow this, all right? So here, cosecant square theta is equals to 1 plus cot square theta. So this case here, I'll get is just understand that sine, cosecant square is just 1 over sine square. So just write this 1 over sine theta square equals to 1 plus cot theta, the entire thing square. So cot theta is given by Cot theta is equal to 3x minus 2. Sine theta is given by root y. So if you're going to replace this in, it will be root y squared equals to 1 plus 3x minus 2 squared. Alright, so this 1 over y equals to 1 plus 3. Should I express? I was just going to leave it because we want this in terms, y in terms of x, right? So I'm going to take the reciprocal. Just remember this entire thing, there's a divide. So y is equals to 1 over 1 plus 3x minus 2 squared. Okay, so that's how I do this question here. Just we need y in terms of x. Let's look at question 8, which is to solve the trigonometric equation here. So we are given that alpha is between minus 90 degrees to 90 degrees, which is negative pi over 2 to pi over 2. So I think firstly, just move the 4 over to the other side. So this is 2 alpha minus pi over 3 equals to 1 over 4. Then we open up sign. What we'll end up getting is plus minus, right? Don't forget about the plus minus there. So square root plus minus 1 over 4, which is actually plus minus 1 over 2. Okay, that's that. Remember that what we have now is plus or minus, right? So this or minus half here. Great. And also take note, the angle that we're solving now is 2 alpha. If you multiply by 2 alpha here, so 2 alpha is minus, just multiply by 2. So here alpha minus pi over 2, this is given. Then this is pi over 2. So 2 alpha will be minus pi to pi. Okay, there's that. Remember that. So this case here, what we need to do is I'm going to find the basic angle of, so let reference angle or basic angle be, say, gamma. Okay, so this will be sine inverse half. So that's the idea. So half, sine inverse half is a special angle. If you key in calculator, okay, so what you do is just sine inverse half in degrees. You realize that it's actually 30 degrees, which is actually, if you divide by 180, that will be a 1/6 pi over 6. Right? So that's the idea. So this will be pi over 6. Okay, this is a reference angle. So essentially, just understand that now you have plus. So this plus for sine positive will be quadrant 1, quadrant 2. And for it to be negative, we quadrant 3 and quadrant 4. Okay, so we have like all the quadrants there. Quadrant 3 and quadrant 4. Okay, understand that. So when we open this up, 2 alpha minus pi over 3. So we have quadrant 1, which is actually just gamma, the basic angle. Quadrant 2 will just be pi minus gamma. Quadrant 3 will just be pi plus gamma. Okay, quadrant 4 will just be 2 pi minus gamma. Okay, so that's that. So I'm going to write this down. This will be 2 alpha minus pi over 3. Gamma will be pi over 6. This is pi over 6 minus pi minus pi over 6 will be 5 over 6 pi. Then you add this up will be 7 over 6 pi. Okay, you just add this up. Pi over 6. Pi plus pi over 6. Okay. Will be 11 over 6 pi. Okay. Now, of which these three angles, all these angles here, we need alpha. So we just add pi, because 2 alpha is between minus pi to pi, right? So 2 alpha here will be pi, we just add pi over 3 throughout. Okay, so you take 1 over 6 plus, say 1 over 6 plus 1 over 3. That'll be half pi. But the thing is, we can't really tell whether it's in the range or not, right? So because we need to add 2 pi or minus 2 pi. So what I'll suggest is from here, 2 alpha. Once you open up the sign here, you just minus off pi. So 2 alpha, just minus off pi over 3 over here. Okay. So we can evaluate. So minus 1 over 3. So you just put minus 1 minus 1/3 here. You get minus 4/3. So minus 4/3 pi, 2 alpha minus pi over 3 then this will be 2/3 pi. Okay, there you go. So essentially ask yourself, which of this is not within the range. Okay, so you don't bring a pi over 3 to the other side first. Okay, that's the main thing. I think what we need to do is just see 2/3 pi. So negative 4/3. So 2/3, this is within 2/3 pi. 7/3 is about this. This is if you think about it, this is actually just 1.16 pi. Okay, 2/3 pi is actually 0.666 pi. Okay, it's 5/6, not in. Oh, sorry. So 5 over, this is not within range. This is not within range. These are all not within the range. Okay, because 5/6 pi is 0.8333 pi. So this case here, you need to make sure it's within this range here. So minus 4/3, negative 4/3 is about negative 1.333 pi. Okay, so this case here, what we need is actually just minus of 2 pi. Okay, because you minus off 360 degrees, you get the same angle here. So essentially what I need is 5/6 minus 2 will be negative 7/6 pi. Then 7/6 minus 2 will be minus 5/6 pi. So 11/6 minus 2 will be negative 1/6 pi. Okay, then you will check whether all these are within the range. Okay, so this will be within the range because this is nothing more than negative 1.166 pi. So this is within the range. This is obviously within the range. This is within the range. Okay, so essentially take those who are within the range. So this case here, 2 alpha minus pi over 3 will be equals to minus 7/6 pi minus 5/6 pi minus 1/6 pi and pi over 6. Then I'm going to add pi over 3 throughout. So I take minus 7/6 plus 1/3. This will be minus 5/6 pi. I put minus 5/6 plus 1/3. That gives us minus half pi plus pi over 3 throughout. Then minus 1/6 plus half 1/3. To be 1/6 pi. Then this will be it, half pi. There you go. Okay, so 2 alpha. So from here, what you need to do is just divide by 2 throughout. So minus 2, 5/12 pi minus 1/4 pi. Just divided by 2, 1/12 pi and 1/4 pi. Okay, so that's how you do this question here proficiently. All right. Okay, let's look at this question, which is to solve this simultaneous equation here. So obviously the problem here is that the x and y for the first equation is in the power. So what we're gonna do is just gonna add them up, right? Just ex plus y plus 3x minus 2y equals to 1. So the 1, we can rewrite this as e to the power 0 if you want to. E0 is 1, right? So then what I'm gonna equate is the index will be equals to the power equals to power there. So it's x plus y. This will be 4x minus y equals to 0. Okay, so from here y is equals to 4x. So I'm going to take 1 sub y equals to 4x into the second equation. Okay, so it's x squared y equals to 256. So this case here, what I get is x squared 4x equals to 256. So we x cubed equals 4x cubed equals to 256. So take 256 divided by 4. This will be x cubed. 256 divided by 4 will give us 64. So open cubic root both ends. 64. You get a 4. Okay, so this is 4. Great. So in other words, y is equals to 4 times 4, which is 16. So in this case here, solving these two simultaneous equations, we have x equals to 4 and y equals to 16. That's about it. So let's look at part B. Part B is slightly trickier. You could see that this is 1 minus 2x and this is 2x minus 1. So what we can do is, and essentially we want, okay, I'm going to let, my trick here is to let, maybe we change this to the same terms. Okay, so giving answer in exact form. They want in exact form, so it's e 2x minus 1, 1, this is 6, e minus 2x minus 1. Now what we can do is if we take the reciprocal, this is 6, 1 over e 2x minus 1, okay, then e 2x minus 1 minus 11. So what we can do is to understand that this over here is a term. I'm going to let v equals to e 2x minus 1. All right, so then that will be 10 v minus 11 equals to 6 1 over v. Then it will be reduced to a quadratic equation here. So this is 10v squared minus 11v equals to 6. So 10v squared minus 11v minus 6 equals to 0. There you go. So check with the calculator. Go to 5, then polynomial, simultaneous, then degree 2. What we have here is 10 minus 11 minus 6. Okay. Key in with 3 over 2 and 2/5. So this would be 5v plus 2, and there will be 2v minus 3 equals to 0. Okay, there you go. So v will just be minus 2 over 5, or v equals to 3 over 2. Here what we'll get is v is e 2x minus 1. Then this is minus 2/5, or e 2x minus 1 equals 3 over 2. Now you can't long a negative number. Okay, you can't long both sides here, so you reject. Okay, not applicable because e 2x minus 1 is a positive number. It has to be a positive number. Okay, so you need to reject the negative. Then after which what we need to do is just ln both sides for this. So it's ln e 2x minus 1 equals to ln 3 over 2. They want the exact form, right? So this is 2x minus 1 equals to ln 3 over 2. So x equals to ln 3 over 2 plus 1. So x is equals to half ln 3 over 2 plus 1. Okay, so that's that. So that's how you do this question here. Obviously, just take note, you just key into calculator and check whether the answer is correct. So the solution here, this x here, just replace it in to the left hand side, and then you replace to the right hand side and see whether the equations they tally or not. So let's look at this question here, which is on kinematics. So in the questions, all distance are in meters and time t in seconds. A particle p at a fixed point O at time t0, the velocity v is given by v equals to 3 sine 2t, where t is at least 0. So for an exact value of t for which the velocity is 0 for the first time after it passes through. So velocity is 0 just means v is 0, just as clear as it gets. So this would be for the first time after it passes. So there, because we could solve a few time here. Okay, so we have we could be sine 2t equals to 0. We know 2t will just be 0. So sine 0, sine is 0. Okay, let's just draw the curve here. Sine is 0. Firstly, when it's 0, right? So like that, sine is 0. Sine x is 0 and it's 0. Pi, 2 pi, 3 pi, and so on. So when 2t, we could write 0. Take note, this is sine x, not sine 2t. So this will be 0 pi, 2 pi, 3 pi, and so on, right? Okay, so for exact value of t, which the velocity is 0 for the first time after leaving p 0. So you take pi here, so t 0 pi over 2 pi 3 over 2 pi. So for the first time will be pi over 2. This is the first time after, because this is when it leaves O. Alright, this is when it leaves O. So essentially pi over 2 seconds. That's it. So the next part is finding displacement. Displacement, we know if we take displacement and differentiate it with the time, we get the velocity. So in order to get displacement, we just need to integrate with respect to time. So displacement, integrating v dt. Okay, so from here, what I'm going to do is just integrate v, which is 3 sine 2t. 2t dt. So this is not too bad. I think this will be just 3 negative cosine 2t divided by 2 plus c. This case here, we know that when t is 0, s is 0. So we can just replace this minus 3 over 2. Cosine 0 is 1. So c will just be, this is 1, 3 over 2. Okay, so hence the displacement will be minus 3 over 2 cosine 2t plus 3 over 2. Okay, so you just replace the c back into the equation there. So you get this expression, displacement, negative 3 over 2 cosine 2t plus 3 over 2. Let's look at part C. Part C will say that find the distance traveled by p. So distance traveled 0, t, within 0 and pi, the time. Okay. So we try to understand this part here. So from here, what we know is t0, you will start from 0 here. So the velocity was initially, after leaving 0, will be positive, right? So this is positive. So it's actually moving to the right. So here, move to here. Now when it changes direction, the moment it changes direction is where t equals to pi over 2, the first time, pi over 2. Okay, pi over 2. Then it travels again. Then the next time it changes direction is where t equals to pi. Okay, take note of this. So t equals to pi is the second time it changes direction. Then the third time it changes direction will be 3 over 2 pi. So that's the idea there. So if you want to find the distance traveled, we need to use a modulus function. So from 0 to, so this will be 0, t equals to 0 to t equals to pi over 2. That's the first one. Okay. Then after which we need to add the distance traveled modulus. This is displacement. The from pi to t equals to pi over 2. Okay. So essentially we take the first distance traveled, add with the second one, the displacement, because displacement is not distance traveled. So just take note of that. There's that. So we're gonna do we have t, right? We have t. We have s, sorry. We have s. So from here, what we're gonna do is just use from 3. I just mod 3. Okay, and this will be a positive number. 3 over 2 cosine 2t. Okay, so you don't really need to mod, but if you want to mod, by all means, so this is 0 plus the modulus of 3 over 2 minus 3 over 2 cosine 2t is 3 over 2 pi over 2. Okay, so there's that. So just put it in 3 over 2 minus 3 over 2 cosine pi, which is cosine pi is negative 1. Then 3 over 2 minus 3 over 2. Do they want exact? They didn't ask for exact, so we could technically just key in calculator. 3 over 2 minus 3 over 2 cosine 2 pi minus L 3 over 2 minus 3 over 2 cosine pi. Okay, so this, the second one I need to mod it. Okay, the first one you can mod it as well, it's fine. So again, eventually will just be, this is 3, this is 0, then that will be 0 minus of 3. So 3 plus modulus mod 3, this will be 6 meters. Alright, so that's it. You want the distance traveled. Just remember the distance traveled, you just need to take the distance traveled to where it changes direction. Okay, so that's how I do this question here. So let's look at this question. The tangent to this curve here, y equals to cubic root of 3x minus y. Even if we're not sure how this graph looks like, we can just draw a random curve. okay, just to try and solve it. Sometimes the diagram that we draw is just to help us to solve the question. So this case here, I'm going to just randomly draw a graph to help us to understand what's going on. So say, for example, there's this axis here, okay, then this axis here. So I know that this graph from x is 0, you get -1, right? So x is 0. So maybe it's just like that. Okay, just draw a graph like that. Doesn't matter. So this is your curve here. So x is 0, this is -1. Okay, we know that when x is 0, we'll get -1. So it will cut the axis here. Okay, so this is y equals to cubic root of 3x minus 1. Okay, let's look at the next one. At point 3 equals to x, meets the coordinates axis at point A and B. So essentially, if I were to draw 3 equals to x here, I'm not sure where's the x here. Okay, so it says it meets A and B here. Okay, so say it's roughly here. This is A, it doesn't matter which is A and B. And the point AA lies on the perpendicular bisector of the line AB. So we need to we need to form the perpendicular bisector equation, right? So slowly, this is 3. Here is 3. Okay. So when 3, we can actually solve for what's the y value. So when x equals to 3, x equals to 3, I'm just going to put this as y equals to cubic root of 3 times 3 minus 1, which is 8, which will give us cubic root of 8 is just 2, right? So this is 3, 2. 3, 2. The coordinates are 3, 2. Then after which, what we need to do is actually just find the equation of perpendicular bisector, right? So we just need to find A. They didn't specify whether A and B is the x-intercept or y-intercept. I'm just going to let it be A and B as such. So we're just going to find a tangent, M tangent. Okay, so M tangent would be just dy dx, right? So when y is equals to 3x minus 1 to the power of a third, then this will be dy dx using chain rule. Okay, chain rule meaning we have an outer layer and then the inner layer. Here, outer layer, then we differentiate the inner layer, right? Here, so the outer layer would be 1/3 3x minus 1. A third minus 1 would be -2/3. Then multiply by the derivative inside. So this outside will give us this guy. Then the one inside here, just remember to multiply by 3. So this is 3x minus 1, -2/3. This will help us to find the M tangent, right? The M tangent we just need to replace by 3. So the gradient of tangent will be dy dx. When x equals to, you just replace x equals to 3 in, be 3 times 3 minus 1, 2/3. Okay, so this is 1/4, I believe, right? You will get 1/4 here. So this is 1/4. So then after which we're gonna just find the equation of tangent. So the equation of tangent here. Okay, we could also just find the gradient, not an issue. So we let A be 0, A. And let B be B, 0. Okay, we know the gradient of M to 3/2 and A to B here. We could just find, right? So let's say this is this point here. Let it be point P. Okay. Okay. So let A B. So we let P be this point. This is B. This is A. After which, what I need to do, we just know that the gradient of AP. Okay. Here AP. AP will be the gradient of AB also, right? Will be gradient of the tangent, which is this M tangent here. Okay, that's that. So what I'm going to do is I'm going to write this down. MAP equals to M. BP is equals to 1/4. So again, do is just use y1 minus y2. So 2 minus A, or rather A minus 2. A minus 2. 0 minus 3 is equals to 0 minus 2, 0 minus 2, 0 minus 2, B minus 3 is equals to 1/4. Okay, so from here, I know that A minus 2 minus 3 is equals to 1/4, and also 0 minus 2, B minus 3 equals to 1/4. Just solve for A and B, that'll be okay. So just cross multiply negative 3 over. Then this is A equals to 2 minus 3 over 4. Okay, key in calculator. That'll be 5 over 4. Okay, 5 over 4. So this case here, that will be 0, 5 over 4. Roughly here. Positive value, 0, 5 over 4. Yeah, okay. So meaning to say, B will be here. Okay, because this is 5 over 4. If A is 0, 0, 5 over 4 here, then means B will be here, which is B comma 0, right? This is M tangent. Okay, so once we're done, B will be, we just cross multiplication. So 4 multiplied with negative 2 equals to B minus 3, minus 8 plus 3 equals to B equals to minus 5. So the intercept here will be minus 5 comma 0. I immediately realized I shouldn't have let this be A because the question contains A as well. A comma A. So you get confused. Maybe I let this A be K. Okay, I'll just change this A to K. So once done, what we can do is we just find the midpoint of AB. Alright. This midpoint here. We were told that one of the this perpendicular bisector here, if I were to draw a perpendicular bisector, it will pass through A comma A. There's a point on the line which be A comma A, which satisfy the perpendicular bisector formula, right? So essentially, what we need to understand is the gradient of the perpendicular bisector will be M1 M1 multiplied by M2 is equals to 1/4 negative 1, right? Okay, so because it's 90 degrees, so the M normal, I'm going to write this down. M normal will just be multiplied by M tangent equals to negative 1. So M tangent, M normal will just be negative 4. Great. Okay, M normal is negative 4. So once this is M equals to negative 4, we could find the equation of perpendicular bisector. Or we could find, okay, basically, yeah, we'll find the midpoint M. Midpoint M will be, we just take the coordinates, is a midpoint of AB. We have two coordinates here, right? We have 0, 5 over 4 and negative 5, 0. So 0, 5 over 4. 0, 5 over 4 and B equals to negative 5, 0. That's great. So the midpoint will just be, we just sum them, the individual coordinates up, then divided by 2. 5 over 4 plus 0 divided by 2. Okay. So this case will get negative 5 over 2, comma 5 over 8. Okay. That's that. Now once done, you could proceed to find the equation of the what do you call it, the perpendicular bisector, but I'm a bit too lazy. I know that the gradient, let the point AA be Q. This is Q. Okay, Q A comma AA, right? Okay, then we know that the gradient of QM is actually negative 4, the M normal. Okay, so I'm going to write this down. Okay, so let Q be AA. Then we know that the gradient of M, the midpoint to Q, will just be M normal, which is actually negative 4. So this is negative 4. So this is, I'm going to take A. The gradient will be y1 minus y2. So it's y1 minus y2 over x1 minus x2, A minus 5 over 2. Okay, so the gradient. So we just take y1 minus y2 over x1 over x1 minus y2. That's it. So then we just multiply both sides. This will be negative 4, A plus 5 over 2, A minus 5 over 8. Okay, that's that. That will be minus 10. Then this is 3 over A. So negative 10 plus 5 over 8. That will give us negative 75 over 8 plus 5A. A equals to negative 75 over 8 divided by 5. So we get A equals to negative 15 over 8. Done. Okay, so that's how you do this question here proficiently. Let's look at question 12, right? So we are given y is ln 3x over x squared. Ask us to find dy dx. I think it's not too bad. This what we need to do is just use quotient rule, right? So this case, remember this is your u, this is your v. So we know that dy dx will be v squared. Okay, so we get v squared x square. So this is if it's using quotient rule, du dx, right? D dx uv, you have v du dx minus u dv dx, right, over x squared. So see, this is your v squared. So this is your v. Okay, v, the denominator is v, numerator is actually your u. So u equals to ln 3x. Du dx will be 1 over 3x multiplied by 3. Remember to multiply by 3. I think some students will forget to multiply by 3, then this will be 1 over x. Then then v is actually x squared. dv dx is just 2x. So using the quotient rule, whereas v squared, v du dx, which is 1 over x, minus of u, which is ln 3x, du dx. So sorry, dv dx, so which is 2x over here. Okay, so this what we get is this simplifying this x, 2x ln 3x, okay, over x to the power 4. We need this to be x cubed. So what we need to do is just factorize the x out. 1 minus 2 ln 3x over x to the power 4. Cancel this one, and this will be 3. So dy dx will just be 1 minus 2 ln 3x over x cubed. Okay, then what we need is a. So a is just 1, b is just -2. They are integers. Great. Okay, so the next thing is understanding how hence find this integral here. So what we need to understand is actually once we differentiate this, we'll get this expression. So I'll just write this down. When we differentiate the previous part, we'll get this as the derivative. So the question now is, what is then, how to get back this expression here, what do we get? We just write this as the integral, right? We get back this, right? So you just start off like writing this out. So from a, we know that the integration of 2 ln 3x over x cubed dx will just be ln 3x over x squared. Okay, you can put a plus c, but you can add it at the end, it's okay. So then once we're done is you realize the integral that you want, this is x cubed, it's actually under here, it falls under here, right? So what you need to do is just split this up. Okay, see this as this is the integral that you need. Okay, then use a distributive nature of this. Just distribute this side, the integral. So this is 1 over x cubed dx minus 2 ln 3x over x cubed dx equals to ln 3x over x squared. Alright, then that will be quite okay. What you do is this integration here is just x minus 3 dx minus 2. So this is the integral that we want to find. X cubed dx equals to ln 3x over x squared. Okay, then once we're done there, we could then just integrate this. Integrate will be, add a power, minus 3 plus 1 -2 divided by -2 minus 2 ln 3x over x cubed. Okay, maybe this x cubed, I just bring it the other side. This is ln 3x over plus 2 ln 3x over x cubed dx. Remember, this, the integral of this is this. Okay, so then just make this a subject. What we want is this, right? This guy here. I'm gonna make this a subject. That will give us 2 ln 3x over x cubed dx equals to minus 1 over 2 x squared minus ln 3x over x squared. So move this over. I move this over to the other side. Okay, then this will be it. So this will be just divide by 2 ln 3x divided by 2. X cubed dx, that will be negative 1 over 4x squared ln 3x over 2x squared plus c. Okay, so that's how we do this question here proficiently. If you have any questions, please do let us know. We have come to the end of our paper. Thank you for watching, and please remember to like this video and share this video with your friends if you find this video helpful. Remember to subscribe to our channel for future videos like this. And if you do need additional help, please do check out our IGCSE online math courses where students and teachers could learn in a safe environment. I personally will answer many of the students' questions there. Do check out the free mini course before signing up for the actual full course, where you can experience learning math in a holistic manner. So I'll see you online and see you in the next video.